In our previous class, we talked about the Riemann-Leibniz fractional integral, and I solved one example on that. Today, we're going to look at the Caputo fractional derivative, I beg your pardon. And here we have the value of our alpha to be 1/2, and f of s given to be x squared. Now, our Caputo fractional derivative is given to be what we have here. This is the Caputo fractional derivative, and we're told from our question that our alpha right here is given to be half, and f of x we have here is x squared. So now let's find the f prime of x. That's the first derivative of x, which will give us 2x. Now we have our value. We're going to substitute all of this into the Caputo fractional derivative formula. So we have our dn alpha, f of x is given to be, and we have our f of x, which is given to be x squared, is equal to 1/gamma of n minus alpha. Then we have our integral from 0 to x. Then we have our x minus t raised to power n minus alpha minus 1. Now our f prime of x in terms of t, here we're going to replace it with 2t, then dt. Okay, now let's substitute the value of our alpha now. Okay, I've already done that for this. So we have our half derivative of x squared is given to be 1/gamma. No, n minus alpha, we have 1 minus alpha into the integral. Okay, 0 to x, we have x minus t, close the bracket. Now when we substitute the value of our n, we have 1 minus half minus 1, then 2t dt. Okay, now we are going to express this integral in terms of a single variable. What that means is that, okay, let's work it out. Then we have this, which is equal to 1/, that is the gamma of half, and we have already established that gamma of half is equal to the square root of pi. So instead of gamma of half, let me replace it with the square root of pi. And then we have our integral from 0 to x of what? X minus t raised to power negative half, then 2t dt. Okay, now we're going to change our variables in order to express it in terms of a single variable. So we have change of variable. Now let's say let our t equal to xu. If our t equal to xu, then we have our dt to be equal to x du. So that is the value of our dt. So let's go back to our formula. We have derivative of x squared now be equal to 2 into this 2 into the square root of pi. Then we have our integral 0 now to 1 of, we have our x minus t. Now our t is equal to xu. So replace it with xu, close the bracket, raised to power negative half. And then xu du. Now I'm trying to factor out our, in order for us to try to factor out the value of x, we're going to have 2 over the square root of pi, then our integral from 0 to 1 of, okay, we have x, then open bracket 1 minus u, close the bracket, then raised to power negative half, and then we have our xu du. Now simplifying further, we have this to be 2x raised to power negative 3 all over 2. Just 2x raised to power 3 all over 2, everything all over the square root of pi. Then we have our integral from 0 to 1, then 1 minus u raised to power negative half, then u du. Now in our previous example, we have already established that our integral, we have already established that our integral from 0 to 1 of 1 minus u raised to power negative 1 all over 2 u du. We have already established this to be 8 all over 3 times the square root of pi. So all we need to do is to replace it back, take it back. So in place of the integral, we put that. So now we have 2x raised to power 3 all over 2 all over the square root of pi. Then now multiply by what we have here, which is 8 all over 3 into the square root of pi. Now simplifying this, if we multiply them together, then we are going to have derivative of x squared to be equal to 16. That's 8 multiplied by 2, that's 16. 16 all over 3 pi x raised to power 3 all over 2. And that is our answer. Thank you very much. For any question, just kindly put it in the comment section and I'll be so glad to attend to that. Thank you.